All right, today we're going to be working on what's called inverses of matrices. Now, you can do inverses of a lot of different matrices, but we are just going to worry about a 2 by 2 because the formula is difficult enough. To start trying to do 3 by 3s and other things just makes it really messy. And then we're also going to determine if two matrices are inverses. So we're going to be able to find an inverse and then also compare two of them together. Now notice it is a 2 by 2. Again, it needs to be a square matrix, just like a determinant. You'll see why in just a moment. But these are our two objectives. So let's go ahead and look at our first key concept. We need to talk about what an identity matrix is. An identity matrix is a square matrix. So a 1 by 1, a 2 by 2, a 3 by 3, so on and so forth. The 2 by 2 identity matrix is labeled I here, and it's the 1, 0, 0, 1. Because when I multiply this, whether I multiply it behind or in front of, I will always get the exact same thing. Now, if it was a 3 by 3, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. It's just the ones that start in the top left and go to the bottom right. If it's a 4 by 4, you have the row of ones and everything else is zeros. So there will always be more zeros than there will be ones. All right. So, I mean, tied or, there tends to be more zeros the bigger that we get. All right. But it has to be square matrix. So if it's not a square matrix, we can't even do this. All right. So let's go ahead and test some things to see if there are inverses. So we want to verify if things are inverses. So we have these two, and we need to determine if they're inverses. So how do we do that? Well, if something's an inverse, when you multiply them together, you should get the identity. So just a aside here, when we're talking about addition, inverses are opposites like 5 and negative 5, because when you get them, when you add them together, you get 0. And 0 is the identity for addition, because when you add 0 to something, it doesn't change. So whenever we put inverses together, we should always get the identity. So like for multiplication, the identity is 1. 5 times 1 is still just 5. 1 times 5 is still just 5. So to get inverses in multiplication, those are reciprocals, 1/2 and 2. If I multiply them together, I get 1. So it's always trying to get that inverse. So what the inverses will always get the identity. So we should be able to multiply these together, and we should be able to get the identity. So if I do x times y or y times x, whichever way we want to do it, we should get the identity. So let's just put this in our calculators and find out. So we're going to multiply these together. Here we do it by hand, and we get 1, 0, 0, 1. And if you have 1, 0, 0, 1, both ways that we do it, then we know that they're inverses. So we're just multiplying them together. Do we get the identity? All right, looking at another one, are these two inverses? Multiply them. Again, we can multiply them both ways and see if we get the identity. So here we go ahead and do p times q, and when we get 1, negative 13, 0, negative 20, that doesn't quite work out. So they're not inverses, and we're done at that point. All right, how do we actually find an inverse? Well, we have a formula. And to find the inverse, and notice the symbology here, a to the negative 1, is found when we have 1 over, this is, if you look, this is the determinant from our last assignment, down minus up, so AD minus BC. And then we do some things with our matrix here. A and D, they switch spots. So D comes up and A comes down. And C and B get made opposites. So it's negative B and negative C. So these just get flipped. This will form a fraction, and then we distribute the fraction, or it's a scalar multiplication. Now notice this little part at the end says the determinant can't be 0 because we don't want 1 over 0, which is undefined. So whenever the determinant is 0, we actually cannot have an inverse. It doesn't have one. So that is a possibility. We have to be aware of that. All right. So let's try one. So here's our values. So we want to find its inverse. Okay. So we first have to do the determinant. Down minus up. So down is 2, up is 0. So that's pretty easy. It's just 2. So then the fraction in front is going to be 1 over 2. So since that doesn't equal 0, we know that there actually is an inverse. And so we're going to continue to find it. So we have this determinant part, and so we have that 1 over 2 that we're going to get down here. And notice what happens with the other ones. A and D switch spots. So if we're going back to our original one, -2 comes up, -1 goes down, and these both become negative. Now, obviously, you can't have a -0, but you can have a -8. So we get -8, and then -2 and -1 switch spots, and the 0. So then we have the 1/2 in front, and we're going to distribute that. So it's the 1/2 in front. So when we multiply it, we get -1, 0, -4, and -1/2. Now notice you will tend to get a lot of fractions on these. That's just kind of how it goes. Inverses tend to do that. Now how can we check it? We can take this and multiply it back by the original problem. And that would test if they're inverses. So can we go ahead and check them? Yeah, we'll multiply these together. And notice we get 1, 0, 0, 1. So we're good. All right, find the matrix, find the inverse of this one. So again, we have to do the determinant. This is -12, and that's -12. And that gives us 0. That's not a good thing. Whenever there's 0, we know that the inverse does not exist. There are some matrix that will not have an inverse. And this one doesn't exist, and you can stop at that point. You don't have to do the rest of it. And that's what I have for you today.